The universe has always hidden more than it reveals. Every star we see, every galaxy we chart, exists within a vast cosmic framework we've never laid eyes on until now. Scientists believe dark matter makes up most of the matter in the universe, yet no one has ever seen it. But what if, in a sudden shift of cosmic rules, dark matter became visible? For nearly a century, dark matter has remained one of the greatest mysteries of the universe, a silent architect shaping galaxies, bending light, and anchoring the very fabric of cosmic structure. Yet, despite accounting for about 85% of the matter in the universe, we've never seen it. It doesn't glow, doesn't reflect, and doesn't absorb light. It passes through us, through planets, through stars, as though it isn't there at all. But what if it was? This hypothetical shift would be nothing short of a cosmic revelation, unmasking a hidden scaffold that has shaped the evolution of galaxies, including our own Milky Way. Suddenly, seeing dark matter would mean more than just solving a long-standing puzzle in physics. It would radically transform our understanding of the universe, our place in it, and even the fate of cosmic evolution. The invisible giant in the room. To understand the scale of such a change, we first need to appreciate what dark matter is, and why it has remained hidden. Everything we experience daily, our bodies, cars, oceans, stars, is made from ordinary matter or baryonic matter. These particles interact with light and other forms of electromagnetic radiation. That's why we can see them. They absorb, emit, or reflect photons. Dark matter, on the other hand, is a different beast altogether. It doesn't interact with light, at least not in any significant way. Scientists believe dark matter particles either do not interact with electromagnetic radiation at all, or do so extremely weakly. That's why it's effectively invisible. Yet its gravitational pull is undeniable. It's the glue holding galaxies together. Without dark matter's influence, galaxies would spin themselves apart, their stars flung into intergalactic space by centrifugal force. The telltale signs of dark matter's existence come from this gravitational fingerprint. In the 1930s, Fritz Zwicky observed that galaxies in the Coma cluster were moving too fast to be held together by the visible matter alone. He proposed the existence of dunkel Materie, dark matter, to account for the missing mass. Later, in the 1970s, Vera Rubin's observations of spiral galaxies confirmed this phenomenon on a galactic scale. The outer stars in galaxies weren't slowing down, as Newtonian physics would expect. Instead, they spun just as quickly as those near the core, proof of a massive unseen presence exerting gravitational influence. But that's where the evidence stopped, until scientists like those from the Atacama Cosmology Telescope collaboration started mapping the universe in more profound ways. Mapping the invisible. In April 2023, ACT scientists unveiled one of the most comprehensive maps of the distribution of dark matter ever created. Using distortions in the cosmic microwave background, the faint afterglow of the Big Bang, they detected the subtle gravitational lensing effects caused by massive dark matter structures. Einstein's general theory of relativity tells us that mass curves space-time, bending the path of light. This effect, known as gravitational lensing, allows astronomers to detect and map dark matter based on how it distorts the light from more distant objects. ACT's dark matter map covered a quarter of the sky and extended deep into cosmic history, back to 380,000 years after the Big Bang. These observations didn't just confirm dark matter's presence, they revealed its vast web-like structure across the universe, connecting galaxies and galaxy clusters like filaments of a giant cosmic spider web. But even with all this evidence, we still can't see it. We infer its presence, we trust the numbers, we rely on gravitational whispers. What if we could finally see it? Let's now shift to our hypothetical scenario. Dark matter suddenly becomes visible. The implications would be immediate and overwhelming. 1. A cosmic ghost revealed. If dark matter became visible, the night sky would change forever. What once appeared as voids between galaxies could be filled with ethereal clouds, vast halos surrounding galaxies, and intricate filaments stretching across space. The Milky Way's dark matter halo, which extends far beyond the visible edge of our galaxy, would shine in this new form of visibility. We'd likely see that the galactic structures we thought were well defined are merely the tip of a much larger unseen iceberg. Earth, too, would be submerged in this now visible substance. Since dark matter is everywhere, it would envelop us, not as a solid mass, but as an ocean of particles silently drifting through us. We might find ourselves seeing a double image of the universe, one layer made of the matter we've always known, and another, vaster layer that had been hiding in plain sight. Second, rewriting astronomy textbooks overnight. Observational astronomy would undergo a revolution. Telescopes designed to capture light in the electromagnetic spectrum from radio waves to gamma rays would suddenly need to share the stage with instruments capable of capturing this newly revealed dark matter. Would we see it with visible light? Unlikely, unless it began interacting electromagnetically. But if dark matter emitted or scattered some form of radiation, even a weak one, our detection capabilities would improve by orders of magnitude. Galactic maps would double or triple in complexity, and theories once thought impossible to test, like the fine structure of dark matter filaments or how it interacts with gravity at small scales, could now be directly examined. This could either confirm or destroy foundational cosmological models, such as the lambda cold dark matter model that underpins modern astrophysics. 3. The end of alternative gravity theories. Some physicists have attempted to explain away dark matter by suggesting that gravity behaves differently on cosmic scales, a concept known as modified Newtonian dynamics. These theories argue that our current understanding of gravity is incomplete, and dark matter is merely an illusion created by faulty assumptions. But a visible dark matter halo, filament, or cloud would be the final nail in Mond's coffin. The gravitational lensing patterns we observe could finally be matched pixel for pixel with visible dark matter structures. It would no longer be necessary to infer or hypothesize, we could see it for ourselves. 4. Solving the mystery of what dark matter actually is. One of the biggest questions in science today is, what is dark matter actually made of? Is it a particle, like the hypothetical weakly interacting massive particles or axions? Is it composed of primordial black holes or something even more exotic? If it became visible, we might gain insight into its composition, density, distribution, and even how it interacts with normal matter. Perhaps we'd finally detect rare collisions or decays that give clues about its particle structure. And with that, we could begin to integrate dark matter into the standard model of particle physics, completing a chapter of science that's remained unfinished for decades. 5. Existential revelations and ethical dilemmas. Suddenly seeing the invisible scaffolding of the universe would challenge not just physics, but philosophy, theology, and the human psyche. We've long thought of ourselves as living in a visible universe. Now we'd see that the structures that define galaxies, the silent companions of planets, and the very arms of cosmic evolution were never baryonic at all. The real universe, what was always there, was hidden. Some might see divine patterns in the newfound webs of matter. Others might feel dwarfed or even afraid by how blind we've been. Would governments try to harness it? Would religious interpretations evolve? Would new myths be born from the foggy halos now swirling above us in the night sky? 6. A new era of space navigation. With dark matter now visible, space travel would take a radical leap forward. Imagine navigating not just by stars and planets, but by the vast, glowing scaffolds of dark matter that stretch between galaxies. These filaments could act like cosmic highways, revealing gravitational currents, safe zones, and high-density regions that spacecraft could avoid or harness. Interstellar journeys, once plotted solely by visible bodies, would now consider dark matter flows and eddies, revolutionizing how we chart the universe. 7. Detecting hidden galactic structures. Astronomers have long suspected that many dwarf galaxies or satellite structures go undetected because they emit little to no light. If dark matter becomes visible, we may uncover entire dark galaxies, collections of mass without stars, hidden in plain sight. These structures could explain galactic asymmetries, strange orbital patterns, or missing mass in gravitational studies. We might find that the Milky Way has far more companions than previously imagined, reshaping our understanding of galactic formation and evolution. 8. New tools for time travel research. While still theoretical, some physicists explore time dilation and wormholes through the lens of extreme gravitational fields. If dark matter became visible, we might locate dense nodes or anomalies where its gravity behaves in unusual ways. These could become the focus of exotic physics research, such as testing relativity, simulating early universe conditions, or even probing theoretical constructs like time loops or faster-than-light travel. The visible presence of dark matter might provide a practical guide to regions of space-time where the ordinary laws of physics bend or break. Is this even possible? Could dark matter ever become visible? In theory, yes, if its interaction with light suddenly changed. This could occur through a change in fundamental constants of nature, decay or transformation of dark matter particles into standard model particles, quantum fluctuations causing temporary visibility under extreme conditions. In particle physics, even minuscule interactions can have universe-wide consequences. The moment dark matter starts coupling with photons even slightly, it would no longer be dark. However, such a transformation would imply a radical change in the laws of physics, a scenario more likely to be observed in science fiction than in observatories. The universe with new eyes. The ACT collaboration's dark matter map was a profound achievement. It showed, once again, that we don't need to see something directly to know it exists. By tracking how light bends, how galaxies rotate, and how the universe expands, we've slowly pulled back the curtain on dark matter. But imagining what would happen if we could see it isn't just idle speculation. It's a thought experiment that underscores how much of reality remains hidden, and how much of our understanding depends on inference, theory, and the bending of light. If dark matter ever becomes visible, humanity won't just see the universe differently, we'll become different. New knowledge, new responsibilities, new frontiers. Until then, we gaze into the darkness and listen carefully for what it reveals. What other secrets has the universe been keeping in the shadows? If you enjoyed this journey into the unknown, don't forget to like, subscribe, and hit the notification bell so you never miss a deep dive into the mysteries of space, science, and beyond.